Hi everyone, and welcome to part 8 of the DMC2 training series. In this video, we're going to take a step away from the actual DMC2 training and focus on setting up the probes that come with the machine. If you're following along this series with your DMC2 machine, you need to complete this setup before going ahead and actually probing any parts. In the last few videos, I showed off the ease of mounting parts in the vise and probing them in, so that the machine knows exactly where the part is sitting. That's a very important and time-saving feature to have when you're doing precision work or multi-operation parts. Both the height puck and the XY touch probe will give you accurate probing results well within 0.01 millimeters, but each one needs to be calibrated for your specific machine. The values that you put in during the software setup are close, but depending on how exactly you bolted in the spindle and probe mount and so on, your probe won't land in exactly the same position as mine when I measured those values and provided them. Calibrating the probe and the height puck are both very simple and only need to be done once. To do this, you're going to need a 123 block, a multimeter, some alligator clips, some 2mm powder coating tape or similar, calipers, and an old end mill or dowel pin. Keep in mind that the purpose of calibrating the probe is to measure the offset in X and Y of the probe's ball relative to the true center line of the spindle. Before you do any of this, you should have already fully assembled and trammed in your machine and machined the top surface of the bed flat and mounted the vise correctly. Before we start the calibration process, make sure that both of your probes are correctly wired in and that your settings are right. Touch the metal face of the height puck on an unpainted metal surface of the machine, and it should light up the probe in light on the diagnostics page in Mach 3. Do the same for the tip of the ball on the round probe, and you should see the same light come on as well. Now you're ready to start calibrating. The first step is to take a clean strip of tape and evenly apply it to the longest side of the 123 block and fold it neatly over the longer sides. We're doing this so that the 123 block can then be placed into the vise firmly without making any electrical contact to the vise. Confirm this by using your multimeter to check. Next, I'm going to load a dowel pin into the collet, which in my case is a 4mm end mill upside down. This should have minimal runout. Now to calibrate the Z-axis, measure the Z height puck in a few places to get the overall thickness of the puck. Write down that number somewhere and then place the clean puck onto the 123 block in the vise. Next, jog the tip of the dowel pin just over the height puck and then click the tool height set button in Mach 3. The machine will slowly move the Z-axis down until it makes contact with the puck and then lift off. Now take two alligator clips connected to your multimeter on the buzzer mode and connect one to the 123 block and the other to the dowel pin. Slowly jog the machine until the dowel pin is just about to make contact with the 123 block. When the dowel pin is getting close, switch to 0.01mm increments and jog the final amount. You may need to use the on-screen MPG in Mach 3 to adjust these increments as well. It's very important that you stop jogging on the exact increment that the multimeter beeps when contact is made. Now look at the Z-axis DRO in Mach 3. And you should see a number close to 0. Here I see the number negative 0.33, so that means my settings have the probe 0.3mm off. To fix this, click the Edit button script setting, and then click on the Tool Height Set button. This will bring up the Z probe script. Find the line that says probe thickness in millimeters, and then subtract the offset that you see in the Z-axis DRO. So basically, if you see a negative number in the DRO, minus a negative number is just adding the positive of that amount. And if you see a positive number, you need to simply subtract that amount. Once you've edited the thickness, save the file and close it. Now you need to repeat the process once more to check if you've gotten the thickness dialed in. So once again, use a height setter, and then install the alligator clip and carefully jog down until the exact point of contact. Now looking at the DRO, you should see 0.00mm in the Z-axis. If you don't, you will need to repeat the process again. So now to move on to the X and Y axes, we're doing a similar process. Before starting, you need to connect the 123 block electrically to the vise for the probe to work. An easy way to do this is to just stick an Allen key in and let it touch the vise. With that in place, stick the magnetic probe on and make sure that the surfaces are clean. Then jog the machine around to the left side of the 1, 2, 3 block, and then click the left to right probe button in Mach 3. Make sure that you're actually probing a flat section of the block and not into one of the holes. When the machine makes contact, the red light in the probe and buzzer should go off, and then the probe will back off a small distance. Now remove the probe and remove the Allen key, then install the 2 alligator clips once again. Just like before, carefully jog the dowel until it makes contact with the same left side surface of the 1, 2, 3 block, making sure that you stop on the exact 0.01mm increment that it makes contact. Now look at the X-axis DRO without moving the machine. We want to see negative 2.00 in the DRO to indicate that the center of my 4mm dowel is currently 2mm to the left of the surface. Or in your case, you would want to see the negative radius of whatever dowel pin you're using. You probably won't immediately, so what you need to do is add or subtract the difference that you see in the DRO. Here I see minus 1.42 in my X-axis DRO, so that means the machine thinks it's currently 0.58mm to the right of where it actually is, since 2 minus 1.42 equals 0.58. Now I take that offset amount and enter it for the gauge thickness variable in the left to right probing button script. If you saw a number lower than negative 2 in the DRO, or lower than the negative radius, then you should be entering a negative number into the gauge thickness to compensate. Save the changes and close the script. Now repeat the process, install the Allen key, install the probe the left face of the 1, 2, 3 block and then remove the Allen key, install the alligator clips, and then carefully jog to the exact 0.01mm increment of contact. Now once again, look at the X-axis DRO, and you should see exactly negative 2.00, or whatever the negative radius of your dowel pin is. If you don't, then repeat the process once again and make sure you're inputting the right number for the gauge thickness. So with the left side probe function done, we now need to move to the right side of the X-axis. Repeat the same process again, this time for the right to left direction. Once again, look at the X-axis DRO. You should see the positive radius of your dowel pin, or in my case it would be 2.00mm. Here I see positive 2.62, so that means the machine thinks it's 0.62mm too far to the right, so we need to subtract 0.62 from the gauge thickness to compensate. Once again, repeat the entire process and then check the X-axis DRO. You should see exactly the positive of the dowel pin radius. In my case, I am 0.01mm off, so I'll adjust that one more time. Once you're finished with that, the X-axis is now completely calibrated and you can move on to the Y-axis. The process is exactly the same as the X-axis, first probing with the Allen key in place, then jogging exactly into position. When you're probing from the front face of the 1, 2, 3 block, you should see negative 2.00 in the Y-axis DRO. If you see a number higher than that, like negative 1.86, then you need to add a positive number into the gauge thickness to compensate, and vice versa. Save, repeat the process, and check that you get the negative of the radius of your dowel pin. And now for the back side of the 1, 2, 3 block, repeat the process, and you should see the positive radius of your dowel pin in the Y-axis DRO. If you see a larger number, like in my case 2.13, then you need to subtract that 0.13 from the gauge thickness to compensate, and vice versa. Repeat the process again to ensure that you get the exact number needed in your Y-axis DRO, and with that you're done. Your probes are now perfectly calibrated to your machine, and you're ready to start using them to machine precision parts. Keep in mind that if for whatever reason you loosen any of the machine frame or the probe mount, you will change all of the distances and need to redo this entire probing process again. It's also a very good idea to write down your offset number somewhere safe, so in case you drop coolant on your computer or something happens and the hard drive dies, you don't have to redo everything the hard way if you reinstall Mach 3. Now, you also may have noticed that this screen set for Mach 3 that I'm using has a bunch of other probing buttons built into the screen. I have not provided the probing scripts for these extra features, but if you are able to understand the default coding language that's there, you can edit them and get them to work on your own. Just using the basic X, Y, and Z functions are generally enough for everything you'll need to do. So that's all for this video. In the next one, we'll look at some general tips for operating and maintaining your CNC machine. Thanks for watching.